Everything you love will be gone one day. Every mountain, every ocean, every star in the night sky. The sun will die. The Milky Way will go dark. Even the black holes, the most powerful, indestructible things in the universe, will eventually evaporate into nothing. And the timeline for all of this? It makes the entire history of Earth look like a single blink. This is how the universe ends. And what, if anything, comes after? Most people never think about this. And honestly, that makes sense. The timescales are so enormous they feel abstract. But here's why this matters. Understanding the end of the universe completely reframes how you think about right now. About stars, about time, about existence itself. And once you see the full picture, you can't unsee it. I've been translating deep cosmology into content that actually makes sense for a long time. And this topic, the death of the universe, is one of the most profound things science has ever mapped out. We're going to go through it step by step, era by era, from where we are now all the way to the final moments of everything. Here's the roadmap. First, we'll cover what's happening to the universe right now, because it's already dying, slowly. Then we'll move through the stelliferous era, the degenerate era, the black hole era, and finally, the dark era. And at the very end, we'll ask the question that scientists actually debate. Is there anything after the end? Let's go. Right now, we're living in the golden age of the universe. Stars are being born. Galaxies are colliding and merging. New solar systems are forming. Life, at least here, is possible. Cosmologists call this the stelliferous era, the age of stars, and it started about 200 million years after the Big Bang, when the first stars ignited. We are currently about 13.8 billion years into this era. But here's the thing most people don't realize. The universe has already passed its peak star formation rate. The universe made stars fastest about 10 billion years ago. Since then, the rate has been declining. New stars are still being born, but fewer and fewer each billion years. The universe is not growing more vibrant. It is slowly winding down. The party started a long time ago, and we showed up after the peak. The stelliferous era will last for roughly another 100 trillion years. That sounds infinite, but it isn't. Stars have lifespans. The biggest, most brilliant ones burn out in just a few million years. Medium stars like our sun last about 10 billion years. And the smallest stars, red dwarfs, can burn for up to 10 trillion years. But even they eventually run out of fuel. One by one, across hundreds of trillions of years, the lights go out. And when the last red dwarf dies, the stelliferous era ends. The universe goes dark for the first time. No new stars, no light. Just the cold remnants of what used to burn. Now we enter the degenerate era, and this is where things get genuinely strange. When stars die, they don't just vanish. They leave things behind. Massive stars explode as supernovae and leave neutron stars. Objects the size of a city but with the mass of the sun. So dense that a teaspoon would weigh 1 billion tons. Medium stars like ours will shed their outer layers and leave white dwarfs. Dense, hot cores slowly cooling over trillions of years. And the smallest stars will simply fade into cold, dark balls called black dwarfs, though it takes so long for a white dwarf to cool completely that no black dwarfs actually exist yet. The universe isn't old enough. During the degenerate era, which lasts from roughly 100 trillion years to about 10 to the power of 40 years, the universe is a cold, dark sea of dead stellar remnants drifting apart. No fusion, no light, just the slow, patient cooling of what remains. And occasionally, very occasionally, random quantum events might trigger brief moments of fusion, a flicker of light in the endless dark, then nothing again. This era lasts so long that our minds genuinely cannot process it. If the current age of the universe were compressed into 1 second, the degenerate era would last for millions of years by comparison. And then something even stranger begins: the black hole era. By this point, even protons, the building blocks of atoms, may have decayed. If proton decay is real, which many physicists suspect but haven't yet confirmed, then all ordinary matter simply stops existing. No atoms, no molecules, no remnants of planets or stars or anything we'd recognize. Just black holes and radiation drifting through expanding space. Black holes, at this point, are the last massive structures in the universe, and they seem immortal. Nothing escapes them. Nothing destroys them. They just sit there, pulling in whatever stray particles drift close enough, growing slowly over incomprehensible spans of time. But here's the twist, and this is one of the most stunning ideas in all of physics. In 1974, Stephen Hawking showed mathematically that black holes aren't truly eternal. They leak, very, very slowly. Through a process called Hawking radiation, black holes emit tiny amounts of energy. Quantum effects at the event horizon cause particle pairs to pop into existence. One falls in, one escapes. And over time, the black hole loses mass. It shrinks, slowly at first, then faster as it gets smaller. And eventually, in a final burst of energy, it evaporates completely. A small black hole might evaporate in a few billion years, but the supermassive black holes at the centers of galaxies, the ones with billions of solar masses, take almost incomprehensibly longer. We're talking timescales of 10 to the power of 100 years. That number has a name, a googol, and even that might underestimate the largest ones. But they do evaporate, every single one. And when the last black hole finally disappears in one last faint pop of radiation, the black hole era ends. And then we reach the final stage. The dark era, there is nothing left. No matter, no black holes. Just an expanding ocean of cold photons, neutrinos, and the faint afterglow of the last evaporating black holes, spreading thinner and thinner as space continues to stretch. The temperature of the universe approaches absolute zero. Not quite there, but so close that the difference is meaningless. Nothing happens. Nothing can happen. There's no energy gradient left to drive any process. The universe has reached maximum entropy, thermodynamic equilibrium, heat death. This is the most likely end according to our current models. Not a dramatic explosion, not a collapse, just a slow, quiet fading into absolute stillness. The universe doesn't end with a bang. It ends with a silence so complete that there's nothing left to hear it. Now, here's the question that scientists actually argue about. Is that truly the end? Some physicists point to something called a Boltzmann brain, a thought experiment suggesting that in an infinite stretch of time, random quantum fluctuations could spontaneously assemble something. Not a universe, not life. Just a brief, random flash of ordered structure popping out of the void. It sounds absurd, but in an infinite timeline, even the absurd becomes statistically inevitable. Others point to cyclical models, the idea that the universe could somehow bounce, that the extreme low energy state at the end might trigger conditions for a new Big Bang, a new universe, a new stelliferous era, a new age of stars. We genuinely don't know if this is possible, but the fact that it's being seriously discussed by serious scientists says something important about how little we still understand. And some theories suggest our universe is just one of countless others, each with its own beginning, its own life, its own end. In that picture, nothing truly ends. It just shifts. Let's bring it all back. Right now, we're in the stelliferous era, the age of stars, already past its peak, slowly dimming. In about 100 trillion years, the last stars go dark and the degenerate era begins, a cold sea of remnants cooling for unimaginable spans of time. Then the black hole era, where the only survivors are the great black holes, slowly losing mass through Hawking radiation until the last one pops out of existence. And then the dark era, heat death, maximum entropy, the end of all processes, silence, forever. Or perhaps the beginning of something we can't yet see. That's the full picture, and it's one of the most extraordinary things science has ever described. Now, I want to hear from you. Which part of this hit you hardest? Was it the heat death? The idea of absolute silence? The Hawking radiation revelation that even black holes die? Or the idea that maybe something comes after? Drop it in the comments. I read every single one, and these conversations are genuinely some of my favorites. If this got you thinking, I've got a video on the biggest structures in the universe, things so large they technically shouldn't exist, that pairs perfectly with this one. It's right here when you're ready. Until next time, nothing lasts forever, but understanding it, that's all ours.